Your FastMCP server is running, but how do you verify the OAuth authentication actually works before deploying? You'll see exactly how to test an AuthKit secured connection with a minimal client script. The example demonstrates a successful ping to the server, confirming the OAuth flow is properly configured and operational. From FastMCP import client, import Asyncio. Async def main. Async with client. http://localhost 8000/MCP. Auth equals OAuth as client. Assert await client ping. If name equals main. Asyncio run main. This demonstrates the OAuth client pattern for secure service communication. The code establishes an authenticated connection to a FastMCP server using OAuth credentials, where the authentication flow is abstracted behind a simple client interface. What makes this distinctive is how it separates authentication concerns from application logic, letting you focus on the service interaction rather than token management. The pattern works by encapsulating the OAuth handshake within the client initialization. When you specify auth equals OAuth, the client automatically handles token acquisition, validation, and renewal behind the scenes, presenting a clean interface for making authenticated requests. This declarative approach follows the principle of least surprise, where complex security protocols become a single configuration option rather than scattered implementation details. This approach matters because it solves the common problem of authentication boilerplate in client applications. Instead of manually implementing token storage, refresh logic, and error handling, you get a production-ready OAuth client in 3 lines of code. It's particularly valuable for microservices, AI integrations, or any scenario where you need to securely communicate with protected endpoints without reinventing authentication infrastructure. The trade-off is framework dependency, but the reduction in complexity and maintenance burden typically outweighs this cost. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the primary interface for connecting to MCP servers. This handles all low-level communication, authentication, and request serialization. Import Asyncio. Imports Python's built-in Asyncio library, the foundation for writing asynchronous code. This enables coroutines like our main, function, and the async with context manager, allowing non-blocking network operations with FastMCP. Async def main. Defines an async entry point. This is the standard pattern for async scripts, allowing the use of await expressions within the function. The async keyword enables non-blocking I/O operations through the event loop. Async with client. http://localhost 8000/MCP. Auth equals OAuth as client. This uses an async context manager to handle the FastMCP client connection. The pattern guarantees proper resource cleanup when the block exits, preventing connection leaks. The auth parameter configures OAuth authentication for secure server access. Assert await client ping. This verifies the connection to the MCP server before proceeding. The assert ensures the server is responsive, failing fast if the connection is broken, while await handles the async ping operation, critical for catching network issues early in async workflows. If name equals main. This is Python's standard entry point guard. It ensures the async event loop only runs when the script executes directly, preventing accidental execution during imports. Critical for reusable modules that shouldn't auto-execute on import. Asyncio run main. This boots the async event loop and executes main, the standard entry point pattern for async Python scripts. Without it, the coroutine would never run, as Python doesn't auto-start async functions at module level. Async client pattern. This minimal FastMCP client demonstrates the essential async pattern for connecting to any FastMCP server, with automatic context management handling both connection and cleanup. The ping assertion silently verifies the connection, but won't catch authentication failures until you attempt actual tool calls. A working client requires just 3 lines: connection string, auth method, and the context manager.
The client that connects to everything connects to nothing until it speaks.